Most homes use electricity as if it were always there. Lights turn on with a switch, refrigerators run all day. Water pumps, internet routers, chargers, freezers, and kitchen appliances work in the background without much attention. In normal conditions, the grid feels invisible. It is not something most people think about until it stops. But household electricity depends on a long external chain. Power has to be generated somewhere else, moved across transmission lines, stepped down through substations, routed through local distribution equipment, and delivered through neighborhood infrastructure before it reaches a single wall outlet. Every part of that system has to keep working. If one part fails, the house still goes dark. This matters because the modern home is organized around continuous power. In some houses, electricity is not only for lighting and convenience, it also supports refrigeration, heating controls, well pumps, communication devices, security systems, and basic food storage. Even when the outage is short, the interruption changes how the home functions. When the outage lasts longer, the problem is no longer only about comfort. It becomes a question of which household systems can keep operating and which ones cannot. Grid interruptions can happen for different reasons. Storm damage is one reason. Equipment failure is another. Maintenance work, overload, fuel constraints upstream, regional disruptions, and damaged lines can all interrupt service. In rural areas, restoration may take longer because homes are spread farther apart. In suburban areas, dependence is often hidden because services feel stable right up until they are not. When grid power fails, the effects move through the house in layers. At first, the lights go out and outlets stop working. Then, refrigeration begins to warm. Internet equipment shuts down unless it has backup power. If the home uses an electric well pump, water pressure may disappear. If heating systems need electric controls or fans, those systems may stop too, even if the fuel source itself still exists. Rechargeable tools, phones, radios, and medical devices become part of the same problem because charging depends on a powered system upstream. That is why many people start looking at ways to shorten this dependency chain, not necessarily to replace the grid completely, but to create a smaller system at home that can keep selected functions running when the external network is unavailable. There are several categories of solutions people use for this. One common format is the portable fuel generator. Structurally, it converts stored fuel into electricity through an engine and alternator. It can run tools, appliances, or selected household circuits, depending on size and setup. Its strength is that it can supply relatively high output for short periods. Its limitations are fuel storage, noise, maintenance, ventilation requirements, and ongoing dependence on combustion and fuel availability. Another format is battery backup. In this setup, electricity is stored in batteries ahead of time and then used later through an inverter or direct current devices. This shortens the chain because power is already on site. Battery systems are quieter and can be used indoors when designed properly. Their limitation is storage capacity. Once the battery is depleted, the system needs another source for recharging. A third category is the grid-tied solar setup. In normal conditions, solar panels generate electricity during daylight and offset part of household use. But many standard grid-tied systems shut down during outages unless they include backup components. This is a structural feature, not a defect. It is designed that way to prevent backfeeding into utility lines during repair work. So while the panels may still be on the roof, they may not power the home unless the system includes battery storage and the right control equipment. There are also hybrid systems. These combine more than one source and more than one storage method. For example, a household may use solar panels for daytime generation, batteries for storage, and a controller plus inverter to make that stored energy usable inside the home. Some setups also allow selective connection to the grid during normal times while retaining a separate backup pathway during interruptions. Structurally, hybrid systems are designed to create options. They can shift between external supply and local supply depending on conditions and the way the system is wired. For many households, this hybrid category is where the practical middle ground begins. It is not the same as building a full utility-scale replacement at home. Instead, it creates a smaller, localized electrical layer that can support specific functions. This might include lighting, refrigeration, communication devices, charging, fans, or other selected loads that matter during an outage. At the household scale, one common format is a hybrid backup electricity system built around 4 basic parts. First, there is the power source. This is often solar, though other charging inputs may also be used. Second, there is the battery bank, which stores energy for later use. Third, there is a charge controller, which manages the flow of electricity into the batteries and helps protect them from improper charging. Fourth, there is the inverter, which converts stored battery power into the form used by common household devices. The way this works is fairly direct. During available charging periods, such as daylight in a solar-based setup, the source sends power through the controller into the battery storage. From there, the inverter supplies usable electricity to selected loads. If the system is designed for essential circuits only, it may feed a smaller sub-panel or a limited group of devices. If it is simpler, it may operate as a standalone backup source for extension-connected equipment or direct appliance use. This is structurally different from relying only on the grid because the home is no longer dependent on a live external line in order to power every selected function. The chain becomes shorter. Generation can happen on site. Storage remains on site. Distribution can be limited to what the household decides is necessary. There are 2 ways people usually approach this format. One is to buy a finished device or package system. In that case, the enclosure, battery, inverter, and charging inputs are already combined into a single unit or matched kit. The other approach is a build-from-plan system using separate components. In that format, the household assembles the system from individual parts based on a documented layout. A build-from-plan system usually includes a materials list, battery type guidance, controller and inverter sizing, wiring arrangement, safety components, and a functional layout showing how power moves from source to storage and then to use. Some guides also show cable routing, fuse or breaker placement, connection order, and the difference between direct current and alternating current sections of the setup. In a more detailed plan, there may also be information about mounting, ventilation, load separation, and how to connect only the circuits intended for backup use. This format is often used because it can be scaled. A smaller version may be set up to cover lighting, phone charging, internet equipment, and a compact refrigerator. A larger version may support more loads, but that also increases component size, cost, and planning complexity. The important structural point is that the system is built around essential loads first, not around powering everything in the house without limits. That distinction matters. A household backup system is usually most practical when it is designed around a defined set of functions. Trying to run every appliance at once quickly changes the scale of the project. But running a smaller set of selected devices is often more manageable because the battery storage, inverter size, charging input, and wiring design can all be matched to known use. This kind of format may be useful for households in outage-prone areas, homes with well pumps or refrigeration concerns, rural properties, or anyone trying to create a smaller on-site power layer for interruptions. It can also be useful for people who want part of their electrical resilience to exist at home rather than entirely outside the property. At the same time, it is better understood as an additional layer rather than a complete replacement for every existing system. The grid still serves a role. So do fuel-based backups in some cases. The value of a household hybrid setup is that it reduces single-point dependence. It shortens the path between the user and the electricity needed for selected tasks. In practice, that means thinking less in terms of unlimited power and more in terms of continuity for essential functions. Which loads matter first? How long they need to run? How they will be charged? And how the system is separated from the broader household demand. For people researching this approach, there are structured implementation guides that document the full format step by step. These usually show the component arrangement, the wiring path, and the household scale setup logic in a way that can be followed over time. One such format reference is commonly shared in the video description for viewers who want to examine how this type of backup system is laid out in detail.